We're going to finish up this chapter in two different sections. One of those sections is talking about solutions and then precipitation reactions, and the second section is going to be with also dealing with solutions, but with molarity and concentration of solutions. And we're going to just start this with a very brief review of what solutions are. We actually talked about this in Chapter 1. A solution is just another name for a type of mixture, and that type of mixture is a homogeneous mixture that we did discuss in Chapter 1, where the two substances are physically mixed together. They're not chemically combined, but they can be separated, but they have only one phase. In other words, it looks the same throughout, like black coffee. It looks the same throughout. And these kind of solutions, they can be a gas within a gas. They can be metal solutions, such as brass that's named here. And then it talks about salt water here, but I want you to be careful about salt water. It's not talking about seawater here. It's talking about like if you stir up some salt in water and then like for a gargle or something like that. And you need to know that the largest quantity is called the solvent. Usually that's water. And then the smaller amount is called the solute. There's some different kinds here. These are called electrolytes and non-electrolytes. We're going to save these for another discussion for another chapter. But I do want us to talk about dissociation in this next slide. Dissociation happens, we're going to talk about these more when we talk about double replacement reactions. This is what happens with ionic compounds. When you put your two ionic compounds, that ionic compound will break apart or dissociate when it reaches that water into its two ions. And this is a very common thing to occur, and this is the example that it gives right here. If you put this acid, hydrochloric in this case, into some water, then it splits apart into the hydrogen ions and the chloride ions. Now please understand that when this dissociation occurs, that it doesn't give the electron back. That chloride that needed to that electron so that it become more stable, it doesn't give the electron back, it keeps it. That transferring happened and it remains. So chloride still has the charge. It kept that electron to keep the charge. So it is a negatively charged chloride ion that's floating around in there, and that hydrogen ion lost its electron, and it still is lost to the chloride, and so it still has a positive one charge. So it is a hydrogen ion that's floating around there. And because they're still dissolved in the water, then it's called aqueous. And these are important when we're going to be talking about the solutions. And whether that dissociation is very complete and most of it or all of it dissociates and breaks apart, that determines whether it's a strong or a weak electrolyte. I want us to get to net ionic equations is where I want to go, and precipitation reactions, because you're going to be required to write those as part of your quiz and part of your homework. So if you have something that's insoluble, that is, it will not dissociate, it will not break apart, it will not dissolve in that water. It's going to stay together in water. And you have a chart that's in your book that I believe I told you about on one of the slides and in a video. Here's an example of one. You have aqueous. Here we have aqueous sodium iodide, and we're putting it together with some lead nitrate, which is also aqueous, which means it dissolves in water and it splits apart. And so we have these sodium ions. Ooh, I need to get a different pen. We have these sodium ions that are floating around. We have these iodine ions that are floating around, independent of each other because they split apart. And then together we're pouring, that's in this beaker, and in this beaker we have these lead ions with their positive 2 charge, and we have these nitrate ions floating around. Notice they stayed together because that's a polyatomic, and they're just floating around in there minding their own business. But when these lead ions bump into these iodide ions here, they form an insoluble lead iodide that will not break apart or stay dissolved in the water, like a rusty nail, or like us, we are insoluble in water, we don't dissolve in water. Then that forces the reaction to occur. That's why these are called precipitation reactions, because it precipitates out. All right. You will need to write the net ionic reaction for this to occur. That's one thing I would want you to do. So the only thing that really matters in this reaction, the only thing that really drives or forces this reaction to happen is the lead and the iodine ions. And together they make lead 2 iodide. Everything else are spectators. They're just floating around watching. So they're called spectator ions. And of course you need 2 of these to make this happen. You need to balance it. Everything else are called spectators. All right. The other thing that I wanted us to talk about, you have solubility. These on table 4.2, which is in your textbook. You will need to be familiar with these. Now, I'm not asking anyone to memorize them for sure, but you will need to know them enough, or at least to know where to look for them. As far as being able to do some homework. All right. And then acids and bases. Please keep in mind, I believe I already told you, the acids are always going to begin with the letter H. Notice all of these start with the letter H. And your strong bases, notice what they end with. They end with an OH. And if you put an acid, a strong acid, especially with a strong base, chances are you're going to end up with water and then an ionic salt. Like if we put hydrochloric acid, one of the strongest acids, with a strong base like lithium hydroxide or sodium hydroxide, you're going to end up with H2O plus LiCl. These are actually double replacement reactions. So why they put these in a separate chapter and call them acid-base reactions, when actually they fall into the category of double replacement. They're just a specialized type of double replacement. So this is HCl. Remember, our 2 ends come together and our 2 middles will stay together. So this is going to make water plus, you're going to write correct formulas. That has a +1 charge, this lithium. This Cl has a -1 charge, so it's LiCl. Lithium chloride plus water. Okay. And those are called Bronsted-Lowry. Bronsted said it produces hydrogen ions. Let's see if there's anything else. These are called neutralization reactions. We are not going to talk about oxidation reduction. That's for Chem 2. That's talked about at length in Chem 2. But oxidation reduction are types of double replacement again, and they're driven by that. All right, so I hope that that clears a few things up for you. I'm going to do another video, and I'm going to talk about molarity in that video.